Good evening, students.
Good evening, ma'am.
Have you all done the assignments?
Yes, ma'am.
We are able to understand. The topic to be covered is basic computer organization and design. This is another chapter in Unit 2. First chapter, register, transfer, and micro operations have been done. In this chapter, we will learn instruction codes, computer registers, computer instructions, and we will touch upon timing and control. Subsequently, we'll deal with instruction cycle. This is very important topic, instruction cycle. And then we have memory reference instructions, input, output, and interrupt, and complete computer description, design of basic computer, and accumulator logic. These are the contents of this chapter. We will start with instruction code. What is an instruction code? When we have to instruct a computer to perform some task, at the highest level, at the more top level, we are instructing the computer to perform the task through operators. Here we are dealing with low level aspects of computer and programming and instructing. If you talk about a high level instruction, if you say 2 plus 3, what is this plus? Plus is nothing but the instruction. You are saying, you are telling computer to add these two operands, add these two numbers. When you go down to this level, you just say ADD instead of this plus. You have to have some instruction code. An instruction code is a group of bits that instruct the computer to perform a specific operation, and it is divided into parts. Instruction is divided into parts, each having its own particular interpretation, which means an instruction would have parts, and each part would have its own meaning. An instruction code is a group of bits that instruct the computer to perform a specific operation. If you have to instruct computer to perform addition, you may say add, or There actually this is add is at this level, and at the lowest level you have the code for the add. The code, let us take the code as 001. If 001 is the code for add, it is at the lowest level essentially. Well, what happens here is, as you go up in this level of abstraction, you see that things will get simplified. And when it is coming from up to down, things would become very specific and bit difficult. How difficult it is to remember the code? It's quite difficult. For add there is one code, for subtract there is another code, for transfer, for add, for increment, for decrement, for every operation there would be a separate code, and you need to remember at the lowest level. When you talk about the hardware, okay, hardware or machine language. After hardware or machine language is which language? Assembly language. In assembly language, you have mnemonics, you have symbols assigned to these codes, numeric codes. And when you go up to a higher programming languages, say C or Java, you don't have to use mnemonics or codes. It is very user friendly, and normal like operators can be used in order to instruct the computer to perform a particular task. Is this point clear to all of you? Is it making sense to you all what we are trying to see here?
No, ma'am.
No, it is not making sense. Okay, let me give you a simple example. If I we both understand a high level language, say English. I can tell you to do something in English. Uh, Pawan, go and bring a pen for me. So what is this? It is like I'm assigning a task.
Instruction to me.
Right? An instruction. This is one way of telling the instruction. Another way of telling the instruction is in our mother tongue. You don't know my mother tongue. Suppose you don't know my mother tongue, I don't know your mother tongue, and I'm trying to tell you in your mother tongue the instruction. And I can't speak properly, then I can't form the sentence properly, then you would not understand the meaning correctly. So that is another way of giving instruction. And you know different languages, or through gestures also I can tell you. Gestures means actions. Suppose we both are you know uh, in front of each other, and I am telling you, go and get the pen, with gesture, with action, with my action. I'm not using any word. That is another way of giving instruction to you. Likewise, to computer system, there are different ways to give instruction. When we talk about the computer system at the hardware level, at hardware level understands which language? Machine language. Machine language is written in which form? Zeros and ones form. So writing the code and giving instruction in zeros and ones form is extremely difficult for us, for humans. Is it not? Don't you think that remembering A code is 65. 65 you have to convert into binary, and then just to write A, you have to write the code for 65. Like that you have to remember for B, C, D, and plus, minus, and so many things. Another method is to go for assembly level language. What is assembly level language? There you use symbols. Instead of 65 in binary form, you would use A directly. That is assembly language. So this one is instructions, computer instruction. To tell computer 2, you have to write 2 in which form? Binary form. What is 2 in binary form? Like this. This is 2. And plus means it is like add. Mhm. Not like, it is add. So to add there would be some code. Let us take 001 code for example. Then 001 and 30011. What does this means? This is an instruction, and this instruction is written in machine language or binary language, all right, which machine directly understands. For instance, our mother tongue, so we directly understand our vernacular language, that is known as vernacular language. No one has to teach us our vernacular language. We know it. But when we you know when we are kids, very small kids, we learn from our parents, elders, and from our surrounding. Then there is nobody to teach us that. So machine language is very native to a computer system. You don't have to teach mm, machine language to computer because it knows it. But for you to learn machine language, it is quite difficult. You know, machine language is very easy for computer system, very tough for human beings. Okay, it is tough. Here it is easy. So there should be another solution. What is another solution? Instead of writing like this, we should write in symbolic form. Have you heard about assembly level language? Programming languages.
Yes,
Programming
ma'am.
languages are divided into low level, high level.
Level.
In low level, you have machine languages and assembly level languages. Assembly level languages comes under low level. Apparently, they have uh, codes. All right. So instead of writing the instruction in binary form, you are writing in symbol. 2 as it is, 2 is the symbol. And 001 means ADD you write. 3 you write as it is. 2 add 3. This is assembly language. This is machine language. And when you move ahead, when you move further to high level language, you you don't have to um, learn these mnemonics. These are known as mnemonics. It starts with P, however, P is silent. These mnemonics, don't have to learn. You have to just learn the when you learn Java programming language or C programming language. What do you learn? You learn their keywords. You learn their operators. You learn their data types. That's why you are learning these languages. Why are you learning these languages? In order to efficiently write programs for the computer system. Otherwise, you have to use this one or that one. But you don't want to use these two. Here, you just have to say 2 plus 3, which is easier. This high level language representation is easier. But this high level language is at the top level of, this is known as top level of abstraction. Okay, that this is a technical term, abstraction. It means that there are so many things that are hidden behind them. That means abstraction. So you have a curtain. Okay, when you put a curtain on the door, behind the curtain there are so many things hidden. So that is known as abstraction. but you want to know what is there in the room. So what do? You remove this curtain, you put it aside, and you enter inside the room. When you enter inside the room, then what happens? You will get to know what is there inside that. If suppose some people don't want to get into the room, they just see the curtain and say, oh wow, what a nice color curtain is. These things you will learn in Java and C. This two things you will learn in computer architecture. Architecture is behind the curtain. What is there behind the curtain? And Java and C is like at the top level. What is there? Now, did you all understand what I mean?
Yes, ma'am.
Very good. Let us move ahead. Stored program organization. What do you mean by stored program organization? Whenever you write a program, remember we are learning these two things, machine language and binary language, machine language or binary language and assembly language. We are not, touching upon or diving into these high level languages. Computer architecture is all about this low level things. It's not about high level things. We will learn about how to represent a instruction through binary code and through mnemonics, and we will learn how to write an instruction in binary form or in,
Ma'am,
yes,
what are mnemonics?
mnemonics means symbols. Mnemonic is a word that is used in assembly language, which are the names. Mnemonics are nothing but the names given to the operations add, and, or, load, store. These are what the operations or the instructions. These in assembly language have been given these letters. ADD means this is one kind of instruction. Inside a computer system, ADD will have one code, binary code. Instead of remembering binary code, apparently you are going for the name of the code, which is known as mnemonics. Understand?
Yes, ma'am.
Oh, good. Stored program organization. You are writing a program. All right. When you are writing a program, to add three, first you say load two, to add three, and then store that result. This is one program in assembly language. When you write this program, it has to be stored somewhere. Where it will be stored? Can anyone tell me? Where are our programs stored? Take Java program or C program.
Memory.
In which memory?
Primary.
Primary memory is, the other name of primary memory is,
RAM.
very good, RAM. In RAM, this program is stored. In this program, we see that there are operators and there are operands. Students, try to understand here. When you say 2 plus 3, what are the operators? 2 and 3
Plus
are
operands.
operands. Plus is
Operator.
operator. So what are these 2 and 3 operands? They are known as data. All right, they are known as data. Here you look at this illustration, how a program is stored in RAM. Memory means this is RAM memory. In this RAM, you have got two partitions. What are the two partitions? The upper partition is for the instructions, which is nothing but the program. The lower partition is for the operands, which is known as the data. Alright, in RAM, our instructions are stored at the top portion and operands are stored at the lower portion. And look at this instruction format. It is divided into here. Here in this case it is divided into two parts. Actually it is divided into three parts. We will learn as we go ahead. This is divided into two parts. And what are these two parts? One is address, another one is opcode. Opcode means what? If the operation is add, it will have one code, binary code 001. Consider that it is 001. So what is this? This is opcode. What is op is add. Operation is add. Operation code is this. And what do you mean by address? Consider your computer architecture notebook. You have, I told you to write notes, class notes at one end and assignment at the other end. All right. And then what typically a notebook contains is a content page or table of contents page. In the first page will have the name, the class fields, and serial number, topic, page number. What is the use of this serial number, topic, and page number? Today we are learning these topics, instruction codes and stored program organization and all. What do? Immediately you open your notes, you write down the serial number, say it is the fifth topic, and the topic name, instruction code, and whichever page number, whatever the page number is, say 49, you write down. What is the use of this? Next time when you sit and start reading, you don't have to search everywhere where the topic is. You can just refer the table of contents. So this is the address. This page number is nothing but the address of the topic, address of this topic. If you don't have this address, if you don't maintain this table of contents, then what you have to do? You have to open the book and sequentially you have to search page by page. Where did you write this instruction code topic? Likewise for assignments as well. If you maintain a table of content and then if you write down which topic questions you are writing on which page, it would be very easy. Then that page number is nothing but the address. In this instruction format, what is this address? This address is the address of the instructions as well as operands. This RAM will have addresses. This has locations. Each location has an address. Like we have, when you come to Nizam College, you will see your MCA block. In your MCA block, your classes will happen in the second floor. So what is the second floor? This is the first address. In second floor, you have your class in room number 821. What is this 821? This is the room number. What is the second floor? This is floor number. And what is this? This is building name. This is your address. Address is quite important. If there is no address, you enter the Nizam College gate and you ask and go to a different blocks and find out where is your class. Likewise, there are addresses for RAM. This, let us take 1, 0, 1, 2, 3, and so on up to here and -1. These addresses would identify where are the instructions and where are the operands. And that address is a part of instruction format. If you would tell a computer system to perform an operation, what operation to perform and on what data, that you are specifying through this address. You are, you know, instructing computer to perform this operation on the data stored in this address. Do you understand this concept, students?
Yes, ma'am.
All right. So here the address is having 12 bit. 0 to 11 means totally address would have 12 bits. Now, can anyone tell me how many locations you get if there are 12 bits?
Ma'am, repeat the question once again.
The address. What is the address? Address is the some number of this RAM, right? Address is 12 bits long. When you say the address is 12 bits long, how many total addresses you would obtain for this RAM?
11. 11.
No, no, 12 bits. We are talking about binary number system. In binary number system, if when we say 2 bits, how many combinations we get?
4, ma'am.
4.
Right. Then, if there are 12 bits, how many combinations you would get?
2 to the power 12.
Yeah. How much it is?
1024.
1024 is 2 to the power 10. 2 to power 10 is 1024. 2 to power 11 is 2048. 2 power 12 is
4096.
4096. So how many locations you have in this RAM if there are 12 bits used for address?
Ma'am, I didn't get it. Can you repeat again?
Yeah, in binary number system, whenever we say that n is having 2 bits or 3 bits or some number of n bits, then how would you find the combinations? Because it is a binary number system, you have 2 to the power of n because there are 2 bits, 0 and 1. That's why you have to use this power method to obtain the total combinations. When n is 2, 2 to the power of 2, you get 4 combinations. When n is 3, combinations in the sense 0, 0, 0, 1, 1, 0, 1, 1. There are 2 bits, you can arrange the 2 bits in 4 different ways. When there are 3 bits, you can obtain 8 different combinations. Likewise, when there are 12 bits, when there are 12 bits, 2 to the power of 12 is equal to how many combinations you would get?
4096.
496.
4096. The one who did not understand. Who did not understand? Who asked me the question? Did you understand? When you uh, take this, 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. Like that, you know this method, right? Power method. 2 to the power of 3 is 8. Like that, when you come to 2 to the power of 12, it would be 4096. Here, this address would be 12 bits long. In binary, this address would be, first address would be 12 zeros. 1, 2, 3, 4, 6, 9, 10, 11, 12. First address is having 12 0 bits. And next it would be 11 zeros and 1. Like that, you go on taking these combinations, and finally you would get all ones. 12. So this is the last address. In instruction format, this address is having 12 bits. 12 bits means totally there are 4096 address locations. And this opcode is here 4 bits. 12, 13, 14, 15. So 4 bits. 4 bits means how many operations you can create from 4 bits?
16.
Yes, very good. 16 operations we can create from 4 bits. And here we can create 4096 locations from 12 bits because it is address. There is a register known as accumulator, which is a processor register. We would learn about it later. Is this concept clear to everyone?
Yes, ma'am.
Okay,
Yes,
Yes,
ma'am.
ma'am.
very good. Let us understand another important concept which is known as addressing. There are two types of addressing. Address. One is direct address, another one is indirect address. This is the demonstration of direct and indirect address. All right. Let me give you an example about this direct and indirect address. Suppose you have a key. Okay. Suppose you have one locker at your home where you keep all your important items. And there is a key of the locker, and this is a locker. Um, okay, this is your locker, and there is a key of the locker. If you put the key on top of locker, okay, if you put the key, sometimes we do know. You put on the top, and then you go and take it out, and then you open it. This is like direct addressing. Direct addressing means you are going only to one place, directly going to your locker. On the top of locker you are finding the key and you are opening it. What is the other way? This is very insecure method, because anyone can um, go to the locker or take the key and open it. Other method, what do? You put the key somewhere else. Okay, somewhere in your bag or in your drawer, somewhere else, not near the locker. So this is your locker. You put your key here. First you go to your drawer. First you go to your drawer, open the drawer, take the key, and then go to the locker and open it. So which is direct and which is indirect? This first method is direct. Second method is indirect because you are using two things. First you are taking the key and from one place taking the key to the locker and opening. So that is second place. This is indirect. Every data and instruction has an address. Okay, every data and instruction has an address. If you store the address of the data in the address part of the instruction, you see here, this is our instruction. All right. Now the question that arises is, how do you distinguish between whether the address is direct or indirect? For that, you need to understand this instruction now has split into three parts. Our instruction has address part. How many bits long? 12 bits. Then opcode, how many bits long? Actually, you learned that opcode was 4 bits, but opcode is 3 bits now. Why opcode is 3 bits? Because you are introducing mode bit. This is known as mode bit. What is the need of mode bit? To distinguish between direct and
Negative and
indirect.
positive. Okay.
Ah, right, very good. That is like that only. When you talk about numbers, this last bit would distinguish between positive and negative numbers. Like that only here. Here it is not about positive and negative numbers. Here it is about direct and indirect address. But the concept is same. Direct address means 0. Here positive means 0, negative means 1. Here direct address means mode bit would contain 0 and indirect address means mode bit would have 1. This is 1 bit. 15th bit is mode bit. 0 to 11 bits are address bits, totally 12. 12 to 14 are opcode. Now how many operations you can create? Can
Right,
anyone?
ma'am.
Yes, very good. You get here 8 operations. And here how many modes you get? 2 modes. 1 bit means 2 modes. If you have 1 bit, 2 to the power of 1 is equal to 2. 0 and 1. Here we get 4096 addresses. In this RAM, we have this instruction stored in the upper part of the RAM. We learned that the top part will hold instructions and the bottom part will hold operands or data. Data is nothing but operand. This is our instruction. What does instruction contain? Address, opcode, mode bit. What is this address? 457. When you go to 457, what do you find here? You find the operand. If you have to perform addition of 2, it is 2 add 3. Consider that one operand is in accumulator. Okay, this is accumulator, which is a processor register. 2 is in accumulator. Then what do you find at 457? Very good. You find
3.
3. And what are you doing on 2 and 3? You are performing add operation. And how do you know that at 457 you would find 3? Because it is a direct address.
Direct
Direct
access.
address means the instruction contains the address of the operand. This 457 is address of the operand. How do you know that it is address of the operand? Because it is a direct address. Now coming to indirect address, you see here we have op, op operation add and the address 300. When you go to 300, are you finding the operand?
No, ma'am.
No. Why?
No, ma'am.
Because it is indirect now.
Yes, because it is. How do you know it is indirect?
The mode bit is 1.
Very good. Mode bit denotes that it is an indirect address, and this 300 is the of the address of the operand. Okay, this 300 is not the address of the operand, rather address of the address of the operand. Here it is indirect. When you come to 300 location, you find 1350. This 1350 is the address of the operand. So see here, you are taking two parts like this, which I told you. First path you have to go and take the key, and you have to go to second. Here it is direct, here it is indirect. Understand, students? Direct and indirect address.
Yes, ma'am.
Very good. Coming to computer registers. What is a register? Can anyone tell me?
Memory in the processor, ma'am.
Very good. Memory in the processor. 1 minute, students. All right. Here, registers is a memory inside the processor. We will learn different registers in the processor now. Can anyone tell me what registers we have already learned? What are the registers that we have already learned? Name?
Ma'am,
Yeah, tell me the names.
uh,
One.
address register and instruction
Very good,
program
very,
counter, ma'am.
very good. 1 minute, huh? 1 minute. Okay, sorry students about that. Um, yeah, very good. Somebody was telling about address register and some general registers also we learned. Can anyone give me the names of those general registers? Does anyone remember general registers? No one remembers? Okay, I'll tell you. Do you remember R1, R2? We did it during arithmetic micro operations. Yes, students.
Yes, ma'am. Logic operations.
No, what did we do? R1 equal to R2 plus R3 or R1 equal to R1 plus R2.
Yes,
Yeah,
Those
ma'am.
ma'am.
are also those are also registers. They are general purpose registers. You know something? You carry one notebook in which you write rough notes or some notes or some uh, you know data material that you are collecting about some topic. That is general purpose book. And then you maintain one book for computer architecture, you maintain one book for Java. What are they? They are specific books. You understand, students, what I'm saying? When you have a computer architecture notebook, you don't write anything else in that. You write only computer architecture that is specific to that course. But you also have one book wherein you can write anything. What is that? That is general purpose. These are all special registers. They have got specialized task to be done. Well, we learned about address register already and accumulator and instruction register. These three, the others we will see now. Actually, we will look at each of them right from data register. The first one is data register, DR. How many bits it can hold? 16 bits. All right. So what will be the address for DR? Can anyone tell me? Bit positions. What will be the bit positions? First one will be
0 to 15.
very good. 0 to 15. This is DR, data register. Its size is 16, but its bit positions are from 0 to 15. And what does it hold? It holds
Data.
memory operand. Yeah, any data. Operand is nothing but data. So it holds memory operand or any data. What is AR? AR is address register. Just we learned about the address in the instruction. Can you tell me how many bits that was?
12 bits.
12 bits. So address register in here in this case is 12 bits and their numbers would begin from
0
0
to 11.
to
11.
11. Yes, very good. 0 to 11. And what is the name of this register? Address register. And what does it holds? It holds the address for memory. Our RAM is there, no? This RAM has locations. Those addresses are held in address register. All right. Next is AC. What is the size of AC? 16 bits. Because AC holds, it can hold the data or it can hold the register address, but it is the most important register in the processor. That's why it is known as a processor register. Its full form is accumulator. AC means accumulator. Its size 16 bits. IR instruction register. We learned that its size is 16 bits and it stands for instruction register and it holds instruction code. Instruction code further has mode bit, operation code and address. The next one is PC. Its size is 12 bits and its name is program counter PC. And what does it hold? This is very important. You should learn it and remember it. It holds the address of the instruction. Can anyone tell me what is the difference between AR and PC?
Ma'am, AR will hold only the address of the memory, but program counter will hold the number. I mean, how many number of operations has to perform on the address? It will store in the program counter.
I'll tell you. You try to understand here. If you don't, you tell me. You ask me. I will explain you. This is our RAM memory. Means this is our memory. This has got instructions. Sorry, addresses. These are okay. I'll change the color. These are addresses. And inside this RAM, it is divided into two parts. Here we have instructions and here we have data. Remember here, PC will hold only these addresses. Means addresses of instructions only. It cannot hold the addresses of data. It won't hold the addresses of data. Only it holds the addresses of instruction. PC can store only these addresses. What are these addresses? These addresses belong to instructions. Whereas AR can hold address of instruction as well as for data. But PC can hold only the address of instruction and not the data. Did you understand this clearly?
Yes, ma'am.
Yes, ma'am.
Remember, this is very important. There is a confusion here. Okay, PC will always store the address of the instruction. AR can store the address of instruction or data, anything. Going forward to this TR, TR is a temporary register. Why do you use temporary register? Can anyone give me an example of temporary register in real life where you that you use in day-to-day life?
One time password.
Yeah, very good. One-time password is temporary password. Very good example. Any other example which is temporary, which you don't use, again and again? Suppose if you have to during the class, tell your friend something funny, then what do? You just tear one piece of paper from your notebook, write something on that, and pass it on. Then your friend reads it, both of you laugh, and you just throw it off. Did you do it or not in your college days? We all have done it. So that is just something temporary. That information, whatever you are writing, that is only for enjoying at that moment, not forever. Like that, here there is a temporary register which will hold the data temporarily. Example is, um, if you have to um, exchange the numbers between these two variables, a is having 10, b is having 20. Now what do you want to do? You want to put 20 in a and 10 in b. So how do you do that? Using a temporary variable. Can anyone tell me how do you do that using a temporary variable?
A is equal to B.
If you say a is equals to b, the data of a will be erased.
Will
Ma'am,
take
we
it.
have to swap the numbers, ma'am.
Yeah, swapping. How do you do using temporary variable?
Will
Ma'am,
take.
I don't know the process of temporary variable.
We'll make one more variable. We
Will
can
take
Yeah,
name
you
it.
any
take
one
one
more
more
variable.
variable t. You take one
Yes.
more variable t. Now you
Yes.
tell me.
Now T is equal to B, A is equal to B, then
T is
again
equal
A is equal to T.
Yes.
a is equals to t equal to b, a equal to b, a equal to no, when okay, t equal to b means t will get 20. A equal to b means a will get 20. B equal to, no, it should be t equal to a.
Ma'am, I think T is equal to A is equal to B, then
Yeah,
B
t
is equal
equal
to
to,
T.
yes, t equal to a. If you say t equal to a, then if you say t equal to a value you are storing in a temporary variable t. So this is 10. T is having value 10. Now a equal to b. Now 10 is erased, replaced by 20. But then 10 you are storing in t. So b equal to t means now b will get 10. So this is like swapping using a temporary variable. Such type of operations can be done by using a temporary register that holds the data temporarily. INPR is input register. Its size is 8 bits and it holds input character. From the keyboard, when you press A, this A has 8 bits of code. Where it will be stored? It will be stored in input register. And OUTR size is 8 bits. Its name is output register and it holds output character. Suppose you have to print A, then you store A in output register and that gets displayed on the monitor. Students, did you understand this list of registers?
Yes, ma'am.
Yes, ma'am.
Okay, all right. Let us go ahead and see here. PC, fast, you should tell me. Okay, I will take the name of the register. You should tell me the size. Okay, randomly. IR
16.
6. So 16 means 0 to 15.
Yeah.
DR
Ma'am,
DR.
DR 16.
16. 16.
16 means 0 to 15.
15.
INPR
0
8.
to
8 bit.
7. 8.
8, 0 to 7. PC,
0 to 11. 12.
yeah, 12 and size 0 to 11. OUTR,
0 to
0
8
7.
to
bit
7.
0 to
8.
7.
no, size, tell me. Tell me that is
8,
range.
8.
8.
8.
8.
8 bits.
Size is 8, range is 0 to 7.
0 to 7.
Okay, if I ask size, you should tell 8. If I ask a range, you should tell 0 to 7. Okay, tell me quickly, AR.
12.
Mm,
Size 12, range is 0 to 11.
Very good. TR,
Size
Size
16,
3.
16 bits.
range 0 to 15.
right. Now, how many uh, locations or addresses which are known as words in memory? How many words will be there in memory? Words means locations or addresses.
4096.
Why? How you got 4096?
2 to the power 16.
2 to the power
Oh, 12, 12.
2 to the power 12 is the address. Now you try to understand this point. Why here you have 16? Understand this. This is memory. Memory has how many locations? 0 to 4095. This is the range. Size is 4096. And how you got this size? From how many bits? 12 bits. And now, how much data is stored in each location? How much data is stored in each location? Each location,
16
yes,
bits.
16 means from size is 16 bits. 16 bits it can store and the range is 0 to 50. Each word is having 16 bits and there are 4096 words. This is like uh, notebooks. Let us take your notebooks example. How many notebooks you would have? 6 notebooks or 8. For labs also if you take. There are totally how many notebooks? 8 notebooks, each having 200 pages or 100 pages. You buy 100-page long notebook. How many such notebooks you are buying? 8, because you have 8 subjects. Here there are 4096 locations, means this is analogous to 8. And each notebook has 100 pages. This is analogous to
16 bits.
16 bits. This is this concept clear?
Yes, ma'am.
Yes, ma'am.
Okay, very good. Now let us look at common bus system. We have developed one bus system. Do you remember?
Yes, ma'am.
Yes, ma'am. Multiplexers with
Yeah, using
multiplexers.
multiplexers and
State, three state bus
yeah,
buffer.
three-state bus buffer. Very good. Using these two different components, we could develop a common bus system. Let us look at the common bus system for our computer that has these registers. Now we consider that our computer system has these registers. That was for we did it for R1, R2, R3, R4. If you recall, you will remember that was for general registers. Now we have got our registers, processor registers, which are having some specific task. How many of them we have learned? AR. Can anyone tell me how many we have learned?
8.
Eight. How eight?
Sorry, ma'am. What's your question? Can you repeat again?
My question is how many registers we have studied just now? Just before to this concept, we learned about registers. How many are they in number?
8, ma'am.
Yeah, eight. List them out.
Address
Ma'am,
register.
data register,
Yeah,
Address
DR,
register,
DR,
accumulator, program
ACM,
counter,
Instruction register.
IR,
input register,
Temporary
Temporary
output
register,
register,
register.
and
TR,
temporary
input
register.
register, output register.
OUTR, TR. Right. So 8. Do you see all 8 of them here? Okay, if I zoom this, it can't fit in the entire screen. This entire one will not fit entire diagram, but we will study in parts. So this is our bus. Because we have 8 registers. Out of these 8 registers, one register does not have a connection to the common bus. Do you see any connection coming out of output register here? This output register is just taking in, but it is not sending out. This out one is not there. Okay, so the connections to this common bus system are from 7 registers plus 1 memory. 1 memory plus 7 registers, which is equal to 8. Okay, so here we are constructing bus using multiplexer. When you have 8 inputs, how many selection lines you should have? Can anyone tell me how many selection lines you should have when you have 8
3 ma'am.
inputs? 3. Why 3?
2 power 3 is equal to 8.
Right, very good. 2 power 3 equal to 8. So when you get 0, 0, 0 combination, first input will be selected. You see in this bus, there are 3 selection input lines, S0, S1, S2. Memory unit is sending on this bus. Memory unit has 4096 words, each having 16 bits. It is giving out information data on the bus. AR register, it sends out the address onto the bus. Also, this address can be fed onto into the memory, and you can perform read and write operations on the memory. And on every register, you can perform 3 operations, which are load, increment, and clear. Clear means what? Uh, Making all the bits to 0. Okay, that is clear. INR is increment. If it is 0, 0, 0, you increment it to 0, 0, 1. Load is Loading means if there is some information on the bus traveling, if this load is 1, then it gets into the address register. When address register has this load bit 1, load bit of all the other registers would be 0. Okay, here you will have 0, here you will have 0, here 0. When you have 0, 0 everywhere and 1 at this address register, then you are loading. This is like loading the contents of the bus into the register. This is loading the contents of the register onto the bus. This is how you know when you have a bus, you get into the bus. Okay, from your home you take the bus, means you are entering into the bus. Some it means you are, suppose you are the data, you enter the bus to travel. You travel through different routes and then you reach your college. After you reach your college, what do? You get down. You get down from the bus. So data will from one register would travel on the bus and would enter into the destination register depending on this load input. Do you understand this bus?
Ma'am, repeat once again.
Okay. Just give a glance to this complete picture of the bus. Here, you have this bus connected to all the registers except output register. Means bus will get the input. Bus will get the input from 7 registers and 1 memory. This is input to the bus. And this side, if you look at the left side, it is output from the bus into the register or memory. Here bus is loading. Trucks will get loaded. In Hyderabad, if you load the truck with some fruit, say apple, you load the truck with apple, truck would travel with apple and reach the destination, say from Hyderabad to some place, say Warangal. So that suppose this is Hyderabad. Here, from Hyderabad, the truck is taking the material and then traveling and reaching, say, to this. Okay, and here unloading. Any register can put out the content on the bus, and bus would carry the content, and that content would be loaded into the register whose LD bit, LD means load bit, is 1. If load bit is 1, then it means that content has to move into that register. Is this point clear?
Yes, ma'am.
Hmm. If you observe here, AC accumulator is having an extra flip flop. What is a flip flop? Can anyone tell me flip flop?
A single bit, ma'am.
It stores.
Yeah, it stores a single bit.
Yes, flip flop is a storage device that stores a single bit. E. E means extended bit of AC. It stores 1 bit, and there is adder and logic connected to AC and E because you can perform addition, subtraction, in the sense that arithmetic and logical and shift operations on the contents of accumulator and extended bit of accumulator. That's why this unit, adder and logic unit, is connected. You can perform computations on AC and can forward that result onto the bus, or can take it back through this adder and logic into itself, and can take the operands from data register, because this data register is also connected to this adder and logic, and to adder and logic input is also connected. If suppose one operand is here, another operand is here, this adder and logic will take one operand from here and one other operand from here and performs the operation. Or suppose if one operand is here and another operand is here, then also this adder and logic component would perform computation on these two operands. Did you understand this part?
Yes, ma'am.
Output register can only take the content from the bus to be displayed on the monitor. To be displayed outside means output device. This bus is connecting only processor, register and memory, not IO devices. That's why this output register will take from bus but send it out to output device. Okay. Um, we have covered three topics, I guess. If anyone is having any doubt, you can ask before moving ahead. Students, if you have any doubt in the assignment questions or in earlier topics also, you can ask.
Ma'am, when we have to submit the latest given assignment?
Uh, Depending on the number of questions, um, you would get the maximum of 1 week, minimum of 2 days.
Okay, ma'am.
Because questions were many, in the last
Yes, ma'am.
assignment. So take
Yes,
1 week
ma'am.
time.
Okay, ma'am. Thank you.
Yes, anything related to the subject which you want to ask me and discuss with me? No, nothing.
No, ma'am.
Everything is clear. When you are writing notes or assignments, how are you feeling about the topics?
Ma'am, while reading that topics, the topics are understandable, ma'am.
Very good. Other students, all the other students, if you complete writing assignment, no, it will really help you during examinations. You don't have to struggle at that time. And when you write, you will learn um, twice as much when you listen. If you, when while listening, you can learn only 10%, but when you write, you learn 20%, double. That's why writing is extremely essential component of learning. Okay, then we will move to the next topic. Actually, it is not about one or two students. It is about all the students. Now I will call the names. You should tell me whether everything is clear or not. Sirisha,
Clear, ma'am.
Pavan,
Clear, ma'am.
Rupa,
Clear, ma'am.
Vinay,
Yes, ma'am, it's clear.
Vani,
Yes, ma'am, it's clear.
Hima, Varsha,
Clear, ma'am.
Hardik.
Yes, ma'am. It's pretty much clear everything. I have few doubts. I'll ask you later.
What doubts you have?
Now about micro operations. I was going through today. I was going through micro operations, so I have one or two doubts. Uh, I don't think it's more important.
No, it is important. Hardik, I think like this we can you all can learn from each other. You ask a doubt, let us see whether anyone from your peers, means from your classmates, can solve it. Ask your doubt. Anyone who is there in the class can raise the hand who can give solution to Hardik's question. Hardik, tell, ask.
Yeah. Give me a minute, ma'am. Let me open my PDF.
Yeah, open it, and meanwhile I'll complete asking to others.
Sure, ma'am.
Let us see whether anyone else can answer the question. Um, Charchita, are you there? Yes. Um, Name is Charchita Kashapogu. Perhaps he is not in the class. Means virtually present but physically absent. We used to say you are physically present and mentally absent, but now the quote has been reversed. Virtually present and physically absent. Sai Priyanka,
Yes, ma'am, it's clear.
Kavita, Rakesh.
Clear, ma'am.
Okay. So I do one
Ma'am,
thing. Yes, Kavita.
ma'am, it's clear, but while drawing the diagrams,
Mhm.
it's some difficult to understand how
What
to
is it?
draw and
Tell me. Precisely you ask me the question.
okay.
Which diagram? Where are you finding it difficult?
That combinational 4-bit circuit.
Combinational 4-bit circuit.
Yes, ma'am.
Which one? Which combinational 4-bit circuit?
Ma'am, you give assignment in in that
Multiplexer?
one.
Is it multiplexer?
No, ma'am. It's
Automatic
only
automatic
Arith-
micro operations, ma'am.
Adder? Adder? And in arithmetic micro operations, we studied about adder, subtractor, and arithmetic circuit. Which one you are talking about? And binary incrementer as well.
Hello,
Where were
ma'am.
you?
Clear, ma'am.
Kavita, 1 minute.
mm,
Charchita, where were you?
okay, ma'am.
న్యూస్లో పడ్డది చూసుకోలే మేడం చూసుకోలేదు అనేసి ట్రై చేస్తున్నాను.
Acha, is your name Charchita?
Yes, ma'am.
Okay, means this icon, the image is showing a boy image. I thought you were a boy. So, Charchita, tell me, is
Yes,
everything
ma'am.
clear to you, all the concepts?
Hmm.
Have you started writing assignments? All right, students, I will conduct one exam. Um, one mini exam in the chapter of register transfer micro. After completion of every chapter, I will conduct exam. Okay.
Okay, ma'am.
Okay,
When
ma'am.
Okay, ma'am.
it will be through Google Form. So when I will conduct after 2 days.
Multiple
Okay.
choice questions, ma'am.
Yeah, multiple choice questions. After every chapter, if we conduct exam, then we will know how much you are learning and retaining. Okay, now Kavita, you tell me which circuit you are finding it difficult.
Ma'am, 4-bit combinational circuit shifter.
4-bit combinational shift. Oh,
Circuit shifter.
okay, shift circuit. Okay, I will explain it. And
Oh,
not I, somebody. Oh, where is Vamshi? I told him to explain arithmetic circuit. Okay. Someone should explain. Pawan, can you explain shift circuit?
Ma'am, when?
Ma'am, I was facing the same problem as Kavita told in this 4-bit condition combinational circuit shifter.
Okay. All right. Yes, Pawan, what you were saying?
Ma'am, when I have to explain about the topic?
Now,
What was the topic, ma'am?
now, on this, I will just project that top with that circuit. You have to explain it. This one. Your peers are having doubts in this circuit. Can you explain this?
Ma'am, you already explained that, na?
No, that they have doubt. You explain now. Can you?
Ma'am, little bit confusing, ma'am.
What is the confusion?
Ma'am, that functional table, ma'am. That's it. Otherwise,
Oh, you know something? I told you just now when you listen, 10% you will retain. When you write, 20% you will retain. And when you explain, 80% you will retain. So, explaining is a very good method of learning. What is the doubt? Function table. What is the doubt in the function table?
notations, ma'am. You explained, but
Hmm.
quite difficult to remember that. If at all I have completed the assignment, then I would have explained that, ma'am.
Okay, Pawan, no problem. Sirisha, can you explain? Okay, let me take an example and explain to all the students so that this confusion will go away. When I'm asking, you're saying you are clear with everything, and don't keep the doubts with you. Ask me so that we can complete it then and there.
Ma'am, it's easy to write with pen and paper, but quite difficult to explain.
It
Yes, ma'am.
is not difficult. Uh, Let us take 1011. Okay, this is A naught, A1, A2, A3. The output you are getting is H naught, H1, H2, H3. Okay. Now, when this circuit will function as left shift, when the select is
One.
1, it is left. When the select is 0, it is right.
Right.
Okay, let us consider first select 0. Okay, select 0 means it is right shift. In right shift, what do we do? We
We are
perform
shifting the bits towards the right position.
towards the right position. So here, this 1 would come here. This 0 would come here. This 1 would come here. And here you are inputting something. Okay, so how they are writing is,
And this is the left shift.
this is left shift, this is right
Okay.
shift. By shifting it to right, no?
Right shift it
Left
is.
shift will be like this. 1 0 1 1. If you shift like to left side, this will be left shift.
Yeah, okay.
If you shift to right side, it will be right shift. Okay, so what they have done is they have used the terminology in the reverse order. There is a serial input here. There is a serial input which is 0. This is H0, H1, H2, H3. H0, to H0 you are giving serial input, means 0. 0 would come here. In the place of H0 it is 0. Then what are you doing? You are shifting A0 to, okay, this also they are, okay. Here they are using numberings in this order. That's why it is getting confused. This is A0, A1, A2, A3. So now A0, this is A0, right? This is A0. A0 has shifted down. Downwards is right shift, upwards is left shift. A0 have become H1. Let us see here. Yes, A0 has become H1. For H0, we are doing serial input 0. You are transferring 0 here. H is output, A is input, right? So H0 would be 0, which is serial input. H1 would be A0. Okay. H2 would be A1. See, it is shifting right. H2 is A1. H3 is A2. Is this clear now?
Yes, ma'am.
This one is clear, no? Okay. Let us take for left shift. For left shift, select would be 1. Means if selection S is 1, then it is left shift. So this is A0, A1, A2, A3. Let us take output in blue color, H0, H1, H2, H3. Here, H0 would get A1 because this is serial out. You are eliminating this bit, no? A0 is coming out. H0 is equal to A1. Okay, this is H0 is equal to A1. Okay, right, no, we got it. No? This is A1, this is H0. Then H1 is equal to A2. This is H1, this is A2, this is 1. H3 is equal to, this is serial input. From here you are getting. From here you are getting serial input for H3. Here, this one. This A3 is coming out, eliminating. Here A0 is eliminating. So here you will not find A3 in right shift and you won't find A0 in left shift. And you are taking in serial input at, this is known as high end, this is known as low end. Okay, this at low end you get a serial input for left shift because you are shifting left at right side. When you shift to left at right side there will be an empty position. When you shift to right at left side you will get an empty position. I gave an example of your bench. Yeah, if on a bench 3 students can sit, if 2 are sitting here, here and here, if they are shifting to right, then the leftmost place will be vacant. They have shifted, so this will be vacant. If from this side, if they are shifting to left, suppose they are here, 2 students are here, if they shift, then this place will be vacant. So this is serial input and serial input. And this, what does this multiplexer do? Multiplexer takes shift, means selection input line. For 0, all zeros means it is right shift. Okay, when it performs right shift, when S is 0. When it performs left shift, when S is 1. When S is 0, the first multiplexer would receive serial input from outside, and also it loses this A3. It is out. Okay, no, sorry, A naught it loses. It loses A naught because no, again this is in right shift. A3 will be lost. Lost in the sense it is serial out, eliminating. In left shift, A naught will be eliminated or lost. You see here, this is serial input to 0. It is when S is 0, 0 is coming out as output. So you get 0 as output. When S is 0, here also you get 0 output. To 0, what is connected? A naught is connected. So here you get A naught. To this 0, what is connected? A1 is connected. So here A1. To this 0, A2 is connected. This is the output in case of a right shift, which is implemented by having select input to be equal to 0. When select is equal to 1, what happens is, what is 1 here? This one is connected to this A2. This one is connected to A1. Okay, so here output will be A1. So for H naught, output is A1. You see here, for H naught, output is A1. When second multiplexer 1 is there, this one is connected to A2. See here, A2 is connected. Because A2 is connected, here H1 would produce A2. So H1 would produce A2. Here, third multiplexer to 1, what is connected? A3. So this is H2. H2 would generate A3 as output. So H2 would generate A3 as output. What is H3? H2, H3, 1. Serial input is connected. So this serial input is connected to 1 means this one IL. So H3 IL. Now, did everyone understand this?
Yes, ma'am.
Yes, ma'am.
So I hope today's class is useful and you have learned. Now I would wind up. Then again I have class on Wednesday at 10 o'clock. I'll take on that time. You complete assignments by then and I'll prepare some questionnaire. Alright? Okay, students.
Yes, ma'am. Thank you.
Yes, ma'am.
Okay, students, then bye bye. Have a nice weekend.
Okay, ma'am. Thank you. Bye.